WXYZ is a parallelogram. The diagonals intersect at O, such that WY is perpendicular to XZ. Great. Proof that this is a rhombus. Now, what is a rhombus? I believe a rhombus it's similar to a square, where, do you know where on a square all lengths are the same size? So imagine I said that, like that's a square, and that'll be sorry, that's a square, and that's like length 5, and that's length 5, that's length 5, and that's length 5. Yeah, a rhombus would be similar. It's like a parallelogram though. Not all the angles are 90 degrees, but that'd be 5. That'd be 5. They're all the same length. Is that okay? So I have to prove it's a rhombus. Now, how would you prove it's a rhombus? I have to prove that WX equals. So what am I basically being asked to prove? I'm being asked to prove that WX equals XY, and XY in turn equals ZY, and ZY in turn equals WZ. Does everybody understand that's what we're asked to do? Okay. I could try and prove that all 4 triangles are congruent. What would that mean? All 4 triangles being congruent. They're all the same, aren't they? So why don't I list off all 4 triangles up at the very top, and I'll see if we can pull it off all in one fell swoop. So the first one on the left is WOZ. Everybody cool with that? The next one after that? WOX. After that? What is it? X. XOY. Yeah, XOY, my fault. And after that? Oh, ZY or ZOY? ZOY. Now, let's do this quickly, all right? Angle 1 equals angle 2 equals angle 3 equals angle 4. Y. All 90 degrees, aren't they? They're all 90 degrees. And the other reason is they're also vertically opposite, and they're in straight angles, aren't they? So what can we write here? Which one goes in here? WOZ. That's angle 4, isn't it? Angle 4 equals, what's the one in WOX? 1. What's the one in XOY? And what's the one in ZOY? 3. Now what do I need to write there as the explanation? Vertically opposite and straight angle, isn't it? Vertically opposite and straight angle must add to 180. Is that okay? Everybody cool with that? Okay, next thing. Does it give us anything else? I think, does it say anything about any of them being parallel to each other? Nope, doesn't do anything like that for us. Okay, I could say that WO, is it? Is that O in the middle, lads? How can I say that WO? It's a parallelogram, so that's parallel. Oh, wait, parallelograms make this a lot easier. Ready? So in a parallelogram, I can say that's angle 3 and that's angle 4. Okay, then what else can I say? That's angle 5 and that equals angle 6. What else can we say? Angle 7 equals angle 8. And then what other angles do we have? 9 and 10, all right. I want to prove some of those angles are the same as each other. That would really help. Okay, so I'm going to target the top triangle and the bottom triangle. So what's that? WOZ and what's it? WOX, all right. So what I can say there is we already got angle 1 equals angle 3, don't we? Oh, sorry, that should be angle 10, isn't it? Or 11. Is it 11 angles? I used numbers twice. What numbers did I use twice? All right, so that has to be 10. That has to be 11 and 12. My bad. Okay, you're 11 and you're 12. Is that okay? So in WOX, we can say that angle 12 equals what? In ZOY. Angle 11, Y. Y. Alternate. Okay. We can then say angle 6 equals angle 5. Why? Huh? Third angle or alternate, wherever you want. Alright, we're about to get this now. I can then say that WO equals OY. Why can I say WO equals OY? O bisects. Oh, sorry, not there. What does O bisect? What? Yeah, O bisects WY. All right, who wants me to pause the video and explain it bit by bit again? Hands up. There we go. So, what we've now discovered is that we can now say very quickly that we can now say that angle 6 equals. So we can now say angle 6 equals angle 8. We can say angle 5 equals angle 7. What else can we say? Angle 12 equals angle 9. And angle 10 equals angle 11. And why can we say all that? Diagonals in a parallelogram bisect the angles. Okay, bisect what? The angle. Okay, I'm putting down 3 dots now. What can I say next? Therefore what? What can I say therefore? We already said, did we say angle 7 equals angle 8 and angle 9 equals angle 10? We haven't yet. Okay, which one does angle 7 belong in? Actually, to hell, we don't need to write it. We don't need to do that bad. We can say, why does angle 7 equal angle 10, lads? Sorry, why does angle 7 equal angle 8 again? Alternate, yeah. Why does angle 12 equal angle 11? Why does angle 6 equal angle 5? Alternate. Which one am I missing? Missing 10 and 9, am I? That's all 8 angles into consideration now, isn't it? So what can I just write up a blanket statement here? Alternate angles. Is that okay? Now, if you're doing this by color, here's essentially what I'm saying. All the blue angles are the same. They're all the same size. All the green angles are the same size. Would you agree with that? And finally, all the red angles are the same size. Everybody agreed? Now what do I need next? I need a common length for each one, don't I? So what I can do here is I can pair off. Oh yeah, we have this. Doesn't matter writing it down, okay? We have this nailed, okay? So we've accumulated all our information, haven't we? Now here's what we're going to prove next. We're going to prove one triangle at a time. If that's okay with you, okay? So I'm going to prove. See that blue line? What does that have to equal that blue line? Huh? It's a rhombus. Okay, so look at this. I'm proving the left one equals the right one currently. Is everybody okay with that? So I'm going to prove the left one equals the right one. Let's try this out. So I'm going to try triangle WOZ versus triangle, which one? What is it again? What? XOY. Now get this. Why does angle 4 equal angle 2? Vertically opposite 90 degrees. Everybody go with that? 90 degrees vertically opposite. Okay, I've got the red angle done. Didn't need the red angle, but hell, we'll do it anyway. I just need the green, the blue, and the blue line, don't I, for AS? Just need ASA, don't I? Or can I say I can do SAS as well. I can do anything. I actually have everything at my disposal here. I can do ASA, I can do SAS. I have everything ready to go. It's just a matter of actually writing it down. Okay, I'm going to do ASA still. How do I say angle 8 equals angle 7? Anybody tell me? Alternate. Okay, great. Can I now say angle 10 equals angle 9y? Alternate as well. Now, what do I say next then? WZ equals what? XY. And what do I have there? I have ASA. Is that right with you guys? I'm just going to rub out the other part at the moment just because we've already proved all that, haven't we? And I can use any of it now I want. Now, next part. I'm now going to prove that the triangle on the left is the same as the triangle above. So my target now becomes these two. I'm now going to say that, I'll show you the target I'm going for now. I'm going to go for, sorry, give me a second. Okay, I'm going to go for this one here versus this one here. The left triangle and the top triangle. So what do I call them? What do you want me to call them? WOZ, and who's he against? WOX. And look at this. WOZ versus WOX. Let's start off. I'm going to say the purple side equals the blue side. Why am I allowed to say that? Well, I'm allowed to say ZO equals OX. Why? It bisects it, doesn't it? So bisects. What does it bisect? O bisects X to Z. Right. I have a side. Next, I'm going to prove that the two blue angles equal each other. Why can I say angle 10 equals angle 12? Okay, so let's try this out. Angle 12 equals angle 11. Reason being, alternate. But angle 12 equals angle 11. But angle 11 equals angle 10. Why? Angle is bisected, isn't it? We said it earlier, didn't we? And what do we have then? We now know, therefore, angle 10 must equal angle 12. That makes sense? Angle 10 belongs to WOZ, angle 12 belongs to WOX. All right, we're nearly there. We got the blue ones matched up. Next, I got to match up the two red ones. Can I say angle 1 equals angle 4 and why? What does angle 4 equal angle 1? About 90 in a straight angle. Okay, and what do I have now? I believe I have ASA, don't I? What does ASA mean? Triangle WOZ is congruent with WOX. All right, let's catch up on what I've actually done. Okay, I have proven that this triangle here, do you see where my pen is? I've proven that this triangle here, the left triangle is the same as the one on the right. I've also proved that the left triangle is the same as the one on the top. If I can prove top is equal to bottom, that means all four triangles are the same. Does that roll with you guys? Okay, so once again, I'm just going to rub out WOX and OXY. Is that okay with you guys? Now, let's start with top versus bottom. What's the name of the two triangles? Who's top and who's bottom? WOX is on top, and who's bottom? YOZ. Yoz. Or Zoi. Now, angle 1 equals angle 3. Why? Vertically opposite. Good job. Okay. Next thing. I'm going to say WO equals OY. Can anybody tell me why? WO equals OY. What do we say again? O bisects WY, yeah? Okay. I now want to say that angle 5 equals angle 6. How do I say that? alternate. Angle 5 is on the bottom, angle 6 is on top, alternate. What combo am I going to use here? ASA. So what am I proving here? I've now proved that WOX equals, what's a YOZ? And YOZ equals, anybody? What's the other two of them called? WOZ, and what's the last one? YOX. And we're proving that they're all congruent. Therefore, what must be true? No. Therefore, what are the four sides we wanted again at the beginning? WX, therefore WX equals XY equals ZY equals WZ. This is a rhombus. And done.